Howdy there! I'm Chroma, and today I will be teaching you how to make a first-person and a third-person character in Unity. This tutorial assumes that you've at least seen Unity before, enough to generally understand the user interface, but should be pretty simple to follow along other than that. This idea was suggested by YouTube user Anaquit. So, are you ready? Then let's get started! Let's get started by opening an empty scene in Unity. Now, I want to try something different with this tutorial than I've done previously, in that I want to kind of flip back and forth between what we currently have and the finished product, so you can see better how it's coming along and getting towards the finished product. So, starting off here, let's begin by making the environment that our players will move around in, so that we can tell that our players are actually moving and all of that sort of stuff. So we're going to start off by making some folders to store both the scripts that we will be making and the materials for our environmental objects. So we're going to start then by making a folder called materials. And then in that, we're going to right click and hit create material down here. And we'll start by making one for the floor. And we're just going to make these some simple basic colors. So we're going to color this one yellow. We'll make a new one for a block that we will be making, if I can spell correctly, and we'll color this a blue because why not? And then making one more down here called block 2, and then we will be coloring this a green. And I don't think this one did not color correctly. There we go. So we have our materials now, and then we will make another script that we will use momentarily called scripts. That will store the code for our players, the code that we'll be using to move our player and turn the camera. So now let's start setting up our scene here. We'll start by making the environment that we just made our materials for. So we're going to start off by making a cube by right-clicking and then hitting 3D object cube. You can also go to create 3D object cube. There's a few different ways to do it. So starting off with this cube here, let's rename it to floor, and then over in the inspector here, let's make it very thin so that it can act as ground, and then we'll make it really long on both the X and the Z axis by changing its scale to 100 and 100. Going to the scene view for a minute, we can see that is quite large compared to where our camera and light are. Now, let's, to assign a material to it, in the scene view, you have to be in the scene view for what I'm about to do to work, not the game view. We can simply drag our floor material onto the floor here. If we were in the game view, it simply wouldn't work the way that we want it to. As well, if there was other things in the way of the object, then that would also prevent you from being able to just drag and drop a material onto it. But anyways, so now we have a nice yellow floor here. Now let's duplicate, actually no, let's create a new 3D object as a cube. That's going to be our blocks that we're just going to place around. So we'll just call this block, and then we'll give it our blue material. We're going to move it up a bit so that it's actually resting on the floor. And by just dragging it by the arrowheads, we can see that position of about 0.5 should be resting good enough on the ground for the sake of this tutorial. So we don't need to be that exact. So then just dragging it around, duplicating, dragging, and duplicating all around, just so we can better be able to tell if we're actually rotating successfully and moving as we want to. So then that's enough blue blocks. Then let's copy the block and make it green by, first we're going to rename it to block 2 because I guess it's our second type of block. And then let's try rotating this as well, just for more pizzazz. So then we'll duplicate it and then move it around more. We're almost done here with setting up our environment, and then we'll be getting to actually making our characters. So we have that. So now it does look different than in the finished project I had before, because yeah, the cubes are just in different positions because of the way I just dragged them about. But now we're going to start with our first person player, get that all up and running, and then with the way that we will be doing it, we will be able to use the same code to slightly change the way that our camera works to be able to move the third person player in a very similar way. So let's get started on doing that. So first of all, actually, to sort of tidy up our hierarchy here, we're going to create an empty game object that we're just going to call environment, just to easily store the objects that we have in our scene that are just for our environment. And then we can shift select all of these and then drag them onto the environment game object, and then click the arrow, and ta-da, they're nicely stored away. So now let's start making our player, starting with the first person player. So we're going to create another empty game object that's going to act as the player. Now, because we're dealing with a first person player, we don't necessarily need an actual model for our player. Now, depending on the game you're making, you might have one, because maybe if you look down, you can see the body of your character. But for the purposes of this tutorial, we're not going to be dealing with that. With the third person character, we're just going to make a cylinder placeholder object to tell that we have a character that we're moving around. So now this object here, we can start by just renaming it to first person player, as so. And now if you're just making one type of player for whatever game you're making, then you could just call it player or whatever. Yeah, so then we're going to drag the main camera and make it a child object of the player, because we're going to be moving the player, and then we want the camera to move along with it. And then we're going to have separate code on the camera to turn, to have it move up, down, and all around. And now we also want to position our camera better so it's actually with where our player is. So we're going to set the Z component of the position of the transform to 0, and then the Y axis, I guess, we can go to 2, I suppose. That's good enough, I suppose. It might be too tall, or depending on, again, what you're using this for. Now, on our actual player, let's start getting it to move. First, just kind of forward, left, and right, and then we'll work on rotating in a minute. So we're going to start by adding a component. First, something to get it to collide with other objects in the world, namely the floor, in this case, if we have it being affected by gravity, and then the blocks if we bump into them. So we're going to start by adding a capsule collider. You could use any type of collider depending on the way that you're using this, but generally a capsule collider works pretty nicely for most humanoid figures. So we have our capsule collider here, but it's so short along one axis that it kind of looks spherical. So we can start by increasing its height to, say, 2, and now you can see it looks more like a capsule shape. And then we can offset it. We're going to offset it by 1 so that the actual position of the player in the world is based on the floor, like the ground position of the player. This can be useful for different reasons of if you're making whatever you're using the player for in a game, with like ground detection, stuff like that. It can generally be good to have the position of your player be based on its like ground position. Not always, but that's what we're going to do here. So now we have that set up. And as well, based on how the collider is, I'm just going to move the camera back down to maybe 1.5. Yeah, that's good enough. Again, that's stuff you can just mess around with based on your individual needs. So now we have this collider set up. Now we want to get the player to move, we're going to be using the physics engine, and to be able to use physics forces on our player here, we're going to get a component called the rigid body, as we see here. This immediately, without touching anything, any of the settings on it, it'll allow our object here to act under physics. So like falling under gravity, if it was pushed by different forces through code or whatever, it would have friction and drag and air resistance and all of that nice stuff. And then there's lots of settings that we can change here to affect those things, like how strong gravity is, the direction that gravity is. If you had, I don't know, some kind of game in space where you were messing with gravity, stuff like that. The way that drag and air resistance and mass and all that affects the object. Now, for this, we're not going to be really using most of that to keep things simple. Well, we'll be using gravity because that's just simple enough. We're just going to fall and hit our floor here, and we don't really have to do anything with that. Now, let's finally get to the actual code part of moving our player. So in our scripts folder, we are going to right-click and hit create C# script, and this will be the script that'll be moving our player, so we're going to call it player move. Pretty the script name of what it does. So now we're going to double click it and open up Visual Studios to get actually programming this in a second. And then while we're waiting for it to open, we can look over here back on the finished version of the project, this is what the final code is going to look like. So ta-da there. And then we can also see what the final version of the player look function is going to look like. So you can see that if that's what you're looking for. So now that Visual Studio has opened up for the other project that we're now making, the non-finished version. So we're going to start by, so we first want a float for the speed that we will be moving, basically. So we're going to make a public float called speed. Yeah, so that's going to be the speed that we're moving in whatever direction that we're moving in. Next, we're going to want to get a reference to our rigid body to be able to to use physics forces on it. So we're going to type private rigid body, and then we're going to call it RB. That's just a shorthand rigid body, just the name of the variable name, just to not have to type rigid body. So then we're going to be getting that reference in start by typing rigid body equals, or like our RB variable equals get component, and then in angled brackets, or like the greater than less than symbol, then rigid body, and then the close bracket, and then 2 parentheses, and then end of the line. So as well, if you wanted to, you could make this a public rigid body variable and then just drag in the reference. But this is a way that we can do it just to have less public variables in the hierarchy, because we don't really need to. Like, this can be just more optimized, so you're not having to drag in the reference every time. So now that's that. So next, down in the update frame, or update function that's going to be running every frame, we're now going to want to deal with getting input based on what direction we want to move, and then moving in that direction, just to start off. So first, we're going to test if we're getting movement used in the the vertical directions, so W and S, and then we'll deal with A and D in a moment. So then we're also using the WASD keys to move. That wasn't obvious already, I guess. So we're going to type if input dot get key, and you can use either get key down, or get key up, and those are booleans that'll be set to true. Dot get key will be true if the user is pressing that key. If they're holding it down, it'll be true for a while, like for many frames. Dot get key down will be true on the first frame that they press the button. So if you want something to happen, for example, jumping, to happen right when they press the button, then that would be useful for that scenario. And then dot get key up I haven't really found that I use it that much, but it would be useful for if you wanted to do something on the frame that the user lets go of a button, which could be useful for whatever needs you may use that for. So now input.get key. So then the actual key that we want to get is, we get that by typing key code, then dot, and then there's a bunch of options here for specifically what key we'll be getting. So in our case, we're gonna be getting the W key, and it has to be a capital W. So so if the user has pressed the W key, then we're gonna have open brackets there of stuff that we're gonna do. We're just gonna skip that for a moment and just go otherwise if they press the S key, and we can just copy this section of code here and then just exchange the W for an S, and then have more square brackets like that. And then for A and D, we can then have the same deal, just with a D and an A. And then having the benefit of having the else, oh sorry, it would be else if, my apologies. So if this is not true, but this is true, then it's gonna run different stuff. So, and then having the else has the benefit of, if they're hitting both the W and the S key at the same time, they'll just default to moving forward. And if they're hitting right and left at the same time here, they'll move right. Yeah, just, yep, just because. So now going into here. So now how we're actually going to be moving our player is basically setting some floats to 0 or between -1, 0, and 1, based on if we're moving in that direction, moving in the opposite direction, or not moving at all in that direction. And then storing all of that in a vector 3 to get this finalized direction of whether we're moving forward, to the right, in the diagonal, or whatever the case may be. So here we're going to be making, actually I can just copy these variable names over. So we're going to be making 3 more variables here. A float called move vertical, a float called move horizontal, and then a vector3 called move direction. So this will be like the finalized direction of what we were moving. Except we're going to be ignoring the y part of it, but it's still technically a vector3. Just the y component is going to be 0 of it, so that's why that is that. So then down here in W, S, A, and D, so if we hit W, we're going to want to set the vertical one to true. Yes, just confirming there. Whoop, not there, over here. So we're going to be setting then the move vertical to negative, or to positive 1 if we hit W. If we hit S, we're going to set it to -1. And then we're actually going to have another else clause here. So if we didn't press either of those, then we are going to want to set move vertical to 0 because we're not moving in those directions. And then we're going to do the same thing using our move horizontal variable in the D or A part to then move either right or left. So in this case, move horizontal equals 1 if we are moving to the right, move horizontal equals -1 if we are moving to the left, and then otherwise if we aren't pressing any of those, oh, hold on, then we want to set move horizontal to 0. So now we have sort of the directions that we want to be moving in. If we're moving up, left, right, diagonal, that sort of stuff. So now we want to combine all of that and then pass that to a force that we will be applying to our rigid body. So skipping ahead just a bit. So how we're then actually moving our player once we have this finalized direction that we haven't gotten yet, we're going to be doing that through rigid body dot add force, and then we would put in that direction and then multiply it by our speed to have that speed variable be a part of it. Yeah, so now we want to basically calculate that finalized direction. We're going to be storing that in move direction. So starting off, we're just going to define what move direction is with our move horizontal and move vertical variables. So we can just make that a new vector3. And again, this is different than what we had over here, but we're going to be working towards that, just sort of having the natural progression of how we get to what that finalized version of the code looks like. So so we're going to make a new vector3 using the move the vertical first. Yes. So the move horizontal first. Then the y component being 0 because we don't want to move up or down with this script, and then the move vertical. Oh, the move vertical being the z component there. And then the last thing we want to do, oh, that's going to be equals, not in brackets. Yeah. So then the next thing we want to do is if we were moving diagonally, we want to make sure that we're still moving that way with a length of 1, because if we're moving just forward, we're going to be just moving forward with before we apply the speed, let's say the speed was 1, we're going to be moving forward at a speed of 1. If we were moving right, we'd be moving to the right with a speed of 1. If we were moving forward and to the right, those two speeds would kind of get combined so that our speed in that top right diagonal direction would actually be the square root of 2, which is 1.21 something, I believe. So yeah, so we don't want that. We want to make sure that whatever direction we're moving, it's with that length of 1 to then multiply by our speed. So we can do that by, at the end of making our vector3 here, we can just type dot normalized, and that will make sure that it has the length of 1. So now we can then pass that into our move direction and then multiply it by our speed, and then ta-da, we have that. Now then, one more thing before we go back to Unity for a second. When dealing with physics, long story short, without getting too in depth of the why and more complicated behind the scenes stuff, it is so usually when you're dealing with physics stuff, you want to change update to fixed update. That'll just make physics calculations run smoother. The long and short of it. So now going back over into Unity, giving a second for our code to compile, we can now go over to our player and add component, and we can add our player move function and then set a speed to, let me just double check what speed worked here, to yeah, so 2, I guess, and then going into play mode. So now we should be able to, okay, we're rolling, yes. So our capsule here is kind of falling over. One last thing we want to do before we go in actually are testing this. So we want to actually freeze the rotations on the X and Z axis. We'll deal with the Y when we're rotating the, actually, no, yeah, we can freeze the Y too. Yes, so we can freeze all those rotations. So now we're not actually rotating, and now we are not moving. Why might that be? I think this is, oh no, okay, one last thing in our code is that, so when we're doing rigidbody.add force, it is gonna sort of be slowly accelerating with this force at a very small amount. We'd have to put in a really large add force value, a really large speed to be able to get it to be adding the force in the way that we want. We want this force to be more instantaneous because it's like we're pushing our player. So if we put a comma, we can add a force mode. So we can type force mode dot, and we have a few different options here: acceleration, force, impulse, and velocity change. We are going to be using impulse. I believe the default, so if you don't have the comma, there's like a default force mode. It's either force or acceleration. I believe it's, yeah, adds a continuous force to the rigid body using its mass. I believe that's the default if you don't put it in a force mode. We are going to use impulse so that it's more of an impulse force, as the name would suggest. So now a much smaller speed will allow us to move a lot more. So now we're very slidey, but we'll be dealing with that in a second. But now we are kind of moving, so that's pretty cool. We are only moving forward, like to the actual forward, back, left, right directions. If we turned the player, we would not be moving in those directions. So let's get dealing with that. First, let's deal with that slidey slipperiness. So we're going to be dealing with that using something called drag. Now, in our rigid body here in Unity, there is a drag value that already exists, but we're not going to be using that. We're going to be kind of calculating our own drag because this drag affects the drag, sort of air resistance on all axes. If we set this really high, it could allow us to move slower, but it would also affect us on the y-axis, so that if we were to fall, we'd fall really slowly, and then you could overcompensate, or you could compensate with that with increasing gravity, but then you start to run into messes with having really large gravity, and then how does that affect other objects in the scene and stuff like that. So we're just going to calculate our own drag manually that only affects the x and z axes, whatever, so that the y gravity stuff stays the same. So we're going to do that by making a public float called drag, and then down here, we are then going to, at the beginning of each frame, apply our drag as just a kind of cutting down the velocity. So we are going to go rigidbody.velocity, and then we're going to set that equal to, now in order to just multiply this drag by the x and the y, or the x and the z part of the velocity, but not the y part, we can just go rigidbody.velocity equals new vector 3, and then our 3 points of this vector are going to be rigidbody.velocity dot x times our drag, then the y component just being rigidbody.velocity.y without doing anything to it, and then rigidbody.velocity.z again times drag. So this will, yeah, do what we want there. Yes. So now if we go into Unity again, and into play mode, oh, our drag is still set to 0. I'm going to set that to 0.8. That's a value that seemed to work nicely. So now we are moving like a good first-person character controller. So that's nice. Now let's deal with moving in the direction of the camera. So we are going to, in order to do that, we're going to need to actually know what way the camera is facing. So in order to do that, we're going to need to get a reference to our camera. So over here, we get a reference to our camera, getting a reference to the transform component that's going to have the position and the rotation and all of that, because that's all we need. We don't actually need like the camera component or even the game object or anything like that for our uses. So then, to actually then move in the direction of our camera, we're going to need to have some different calculations with how we calculate this move direction here. I'm going to copy this code over and then explain it. So down here, having some spaces so we can see the new code with the old code and then make the changes of how we're doing that. So in order to move in the kind of relative direction of the camera, when we're initially making the move direction part of it, so instead of just having it be a new vector 3 that is the X component of the move, which is the move horizontal, and then the Z component is the move vertical. We are going to instead get the main camera's relative right position, which will be its right position, which has to do with the move horizontal, but it'll be affected by its rotation, the rotation of that camera. So if we multiply that by move horizontal and then add mcam.forward times the move vertical, that'll get us the sort of the same move direction calculation here, just in the direction of the main camera. Basically, yeah, that is how that is done. Then we're having a second line here in that we kind of want to get rid of the Y position of the move direction vector, and then we're normalizing it. And doing that will correct any case of if we're looking up or down with our camera, that we don't want to move up or down. We want to, no matter what we were looking, we're still just constraining our movement to the X and Z axis. So we want to just zero out that Y part and then normalize it. So yeah, so that is that. And that basically brings us to the end of our move function here. And let me just make sure I'm not missing anything. I believe so. We're good to go. So now if we go into here, we'll have to do some manually changing things in the inspector. Oh, well, we have to first get a reference to our, we have to drag our reference of our main camera into there. That's another case where we could have a case of us getting a private reference and then getting the reference through code. But I showed once of how we could get a reference through code. This is fine for just getting the public version here. So now, again, we're still just moving forward, left, right, and down relative to the way we're moving. But now, hopefully, if we rotate our camera to, let's say, 45, now we are still moving forward and back and left and right relative to the way that we're facing. And we can move to any direction and then click back into the game and then be moving in the direction that we are facing. So cool, we have that set up. So next, we want to have code to actually be turning our camera, and we're not doing it manually in the inspector. To do that, we're going to make another script. So we're going to go to create C# script, and this one will be called player look. I guess that's, yeah, just the name of the script to be more script. And you could probably have both these scripts in the same script, but I like to separate the different parts of what is making the player. Actually, no, actually, I take that back. For the specific way of how we're using it, you would want them to be different objects because we're going to be attaching this one to the camera to actually get it to rotate. So never mind on that. So now to get the player to look, we're going to want to get information from the mouse and the way that it's moving up, down, left, and right to have the mouse be turning the player. So going back to the finished version of the code, the finished version of the player look code. So we're going to be getting a public reference to, so we're going to have a public float that is the rotation speed. That is the mirror of the speed here, of the speed that we're rotating. And then we're going to be having a private float that is like rot X and rotation X and rotation Y. And then those will be values that we're messing with to make our camera move up, down, left, right. All right, so then, yeah, so first of all, let's copy these variables over just so I don't have to retype them out. And we're going to get rid of this lock cursor one because we'll be explaining what that is later, just taking things one at a time. Yeah, so then starting off here, we're going to want to be first setting the rotation X and the rotation Y to, because they're going to represent the, over in the inspector, they're going to represent the X part of the rotation. If I go to the game view real quick, the X part of the rotation and the Y part of the rotation. And we're not caring about the Z because we're not going to be rotating the camera like this at all. So yeah. So we want to first get what those starting values of the X and Y rotations are. And we can get that using, so rot X equals, this would be, yeah, so transform.rotation.eulerangles.x, and then, yeah, so the transform of the object that we're currently on dot its rotation, which is going to get that as something called a quaternion, which is not what we're seeing in the inspector. To get the three values that we're seeing in the inspector, we have to then type dot Euler angles, and yes, it's pronounced Euler, I believe. So then we're getting the X component of that. Then we're going to do the same to the Y, except changing these X's to Y's, basically. So that's that. Now we want to deal with actually rotating them, and we're going to do that through something called the like input.getAxis, which that's going to need some explaining over in Unity what those are. So going over to edit and project settings. Yes. Now under these different project settings, there's one called input, and that has something called axes. If we expand that, that has a way that Unity can handle certain input things. So basically there's different values here, one called like vertical, horizontal, fire 1, fire 2, and these are mapped to different buttons that you can then get these axes. And this can be good for getting input in a different way, where you can more easily get values, like how do I put this? Getting values that are, so if you're using like the WASD keys, having the values like slowly go to 1, -1 in the way that you get them. I prefer usually to just get the values manually and handle them myself in terms of how I want them to slowly go towards like 1, -1, or whatever. But for this case, for the mouse movement, we're going to be using .getAxis for these. So doing that, there's this input axis called mouse X here that's getting the mouse movement on the X axis, and then mouse Y that's getting the mouse movement on the Y axis. Now, for some reason, the way that it's getting these axes is kind of reversed for how they are compared to how they are in the inspector. In that, mouse Y is actually, if I go to, actually I can exit this out now. So XY is like the up and down, even though that's the X rotation if we were rotating the camera, and then the mouse X in that axis is treated as what is the Y when we rotate. So we kind of need to flip them in code, as we see here. So how are then getting those axes and then using them? So we're using input.getAxis mouse Y, and then we're storing that in rotation X because of the way that it's flipped. That's just the way that they are. So I'll just copy all this and then explain it over in our other code. So we are taking the rotation X, and then we are adding to it getting that input that is the mouse Y of the way that our mouse is moving up and down. And then just the way that it also is I had to take the negative of it for it to, otherwise it was kind of inverting the way that it was moving. Again, some of this is just trial by error. Initially getting that value, seeing that it was flipped, and just having to make this negative for it to work the way that we want it to. So then we're taking that, we're multiplying it by the rotation speed, and then we're doing the same for the Y rotation with mouse X. And then after that, for both of them, we are multiplying them by something called time.delta time, which will basically make it so that if we mess with the time speed of the game, so there's something called time.timescale. So if we wanted to make the game slow motion, or if we wanted to pause the game, stuff like that, that'll make it so that the camera is still rotating at the same speed relative to that slow motion or freezing the game, stuff like that. So it's generally good to multiply by time.delta time. That is something you don't need to do when dealing with physics, because the physics has its own way of dealing with that timescale stuff. But when we're not doing that, when this has nothing to do with physics, then yeah, we want to multiply by time.delta time if we want to do that. Anyways, then another special thing here is that we want to, for the X rotation, and again, that's rotating up or down, we want to make sure to confine it to not be able to rotate up too far or down too far, because just generally the way that a first-person camera works, you don't go back, like you don't go up so far that you're then looking behind you, if that makes sense. So in order to have that work, we're using a function called mathf.clamp, and then putting in rotation X between -85 and +85, just to go up and down and have a bit of a buffer, so it's not getting all the way to 90. Yes, so it'll basically make the value, whatever it is, it's going to make it sure that it's between these values. Then we want to actually put these rotation X and rotation Y into the actual rotation of our camera. So we can do that with transform.rotation equals quaternion.euler, and then the vector 3 that is those three vectors that we want our rotation to be, that matches those that vector 3 in the inspector. So we can do that then with rotation X, rotation Y, and then the Z part is 0 because we don't want to rotate on the Z axis. So that basically should make that work. So now if we go back to Unity and then wait for it to compile in just a second, and then add our player look script to our main camera, which can also be done by just dragging it into the inspector here. And now we can give it a rotation speed of, let me see what the rotation speed is here. I set it to a massive number of 200. That seemed to work. Again, also that more of that is just done by just trial and error. So now, hopefully, crossing my fingers here. So now if we move the mouse, we are now actually rotating our camera here. And then we can move in the direction of whatever way we are facing. So now that's really cool. And then we can see also from just the blocks all around that we are rotating the way that we want to be rotating. So that's really cool. Now, one thing you may notice is that the way that the mouse is, it's kind of going around with the screen in a way that we don't really want. Usually in a first-person game like this, the mouse would be hidden, and then you wouldn't really be able to see that. So let's deal with hiding the mouse. That's the last part of this that we'll be covering today, other than quickly moving some things around to create the third-person character. So now, in order to hide the cursor, in the start function, we're going to type cursor, and then dot. There's a few functions here that we can use. So dot visible is whether or not we can see the cursor. We can get that, and then that's a boolean that's either set to true or false, and we can just set it to false, and that will effectively hide the mouse. Then copying that, well, actually I don't need to copy all of it, I just need the cursor part again. Then but that won't necessarily be enough, because even though it's hidden, it can still be moving around and then kind of move outside the game window and then be visible again, which could be a problem. So we also want to lock it to being in the game window. So we can do that by going cursor.lock state equals, and then it already is starting to autofill for us. We have cursor lock mode dot, and then we have a few options here. We're going to use cursor lock mode dot locked. If the cursor mode is locked and when you want to unlock it, then you could just set it to none. Same thing with dot visible to true. So now, before we go back into play mode as well, doing this should successfully hide the mouse the way we want it to. But when we're actually testing stuff in Unity, we might not always want that to be the case. It could be a bit annoying to have the mouse be locked like that while trying to mess with values in the inspector. So then a thing we can have as kind of a debugging option is we can make a public, a boolean called lock cursor. And then we can just be using this for sort of for development purposes, where we can then go if lock cursor is true, then we run this code, otherwise we don't. And for the most part in the game, presumably this would never, like, it would always be true, it would never be set to false. But then while we're testing stuff in Unity, if we want to be able to see the mouse, we can be like changing values in the inspector for whatever reason, then we can be able to do that. So now if we go into play mode, the mouse is hidden and we can move it as far as we want and we cannot see the mouse. But now, and the way you can still get out of this is if you hit escape in the inspector, it will bring the mouse back and undo all that so you can move the mouse around. Or if you were in the executable game or still in Unity, you can just hit the Windows key and that'll kind of bring the mouse back. And then as long as you don't click back into the game window, it won't disappear again. So yeah, so now going on to play mode, we can then also set that boolean to false, and then this should still run the same way, except the mouse will not be hidden. So now we have finished a first-person character. So that's all nice and handy, and it's pretty powerful already how you can expand this. But now let's tweak it to, without making any new code, to make a third-person character. So we're going to do this by duplicating our first-person player and then unchecking it to like hide the original one, because having more than one main camera is a problem. So we're then going to rename this to third-person character. There we go. So now going back to the scene for a second. So we're going to want to first move this camera back to be viewing our player in a third-person fashion. There we go. So then now as well, we're going to want to actually make just some sort of model for what we're actually, like our player that's actually moving around. We're just going to make a capsule that's going to act as our player. And then we can move that up to kind of match with the capsule collider that we made. And because we already made that capsule collider elsewhere, we don't need the capsule collider that was automatically generated on this thing here. So now we can just see that those line up. Nice. We have our cameras kind of viewing it. Good enough. Maybe just back a little further. So then now we want our camera, instead of rotating around itself, we want it to rotate around the player. And how we can do that is by making a new game object that we're going to call camera pivot. Camera pivot. And then this we can have be set on the player, or maybe slightly above, depending on how you want it to be like that in the game. And then we can make the main camera a child object of this camera pivot. And then the player look function that we made and put on the camera, I'm going to hit copy component, and then remove components. So we're going to get rid of it on the camera pivot, and then get rid of it on the main camera, and then instead put it on the camera pivot. So now, ta-da, we now have this camera pivot should be functional. So now we have a character that can move in the same way, except now it's third person and our camera is viewing it from afar. So now we can rotate the camera around. Now the one small thing here is that our player isn't actually rotating at all. So if we had like a cube or something, it wouldn't actually be rotating at all. So there'd be some more code involved to actually get the character to be facing the same way as the camera. But that's more work for another day if you're going down that route, I suppose. So yeah, so now we have a player camera. There would also have to be more stuff done to for things like clipping through the floor and all that. But again, this works for now. It's just a base set of scripts that's very simple and clean and not too long, that already gives you a working character that you can start making a game with. So I think that's pretty cool. So yeah, so with all that said and done, I challenge you to, so we can't actually jump yet at the way that this is currently set up, but I want you to use that. I want you to challenge yourself to make some sort of mini game thing with either the third person player or the first person player, utilizing the fact that you can't jump, and use that as a creative constraint to make something unique. I kind of had a similar challenge with the 2D side scroller thing, and I wanted to apply it in 3D, because then there's more maybe stuff that you can do with that. So maybe there's maybe you could do something where even though you can't jump, there's springs or something in the level that you could have to bounce on to get to higher places, or I don't know, whatever you want to do with it. So that is my challenge for you. So I hope you found this tutorial helpful. If you have ideas for tutorials that you want to see, please suggest them in the comments below. So thank you all so much for watching, and as always, I'll see you around.